In the vast, frozen expanse of the Arctic, a true monarch reigns. Well, it is a world of blinding white, where the line between sky and ice often blurs into a single, shimmering horizon. Here, life exists on a razor's edge, governed by the unforgiving laws of cold and motion. The polar bear, Ursus maritimus, is the master of this realm. It is the largest land predator on Earth, a giant weighing up to 600 kilograms. We see it as a symbol of raw power and endurance. But how does such a massive animal survive, and even thrive, in an environment that should, by all rights, be impossible to conquer? This is a fundamental puzzle, a paradox of nature that challenges our understanding. The question is not just about survival, it is about efficiency. How does this colossal creature walk across thin sheets of sea ice without breaking through? How does it stay warm when the air temperature plummets to -40 degrees Celsius and the water is near freezing? How does it move with such lethal grace, stalking its prey over a landscape of shifting, cracking ice? The answers are not found in simple biology alone. They are hidden deeper, written in the language of physics. The polar bear is a masterpiece of biomechanical engineering, a living demonstration of physical principles applied with breathtaking elegance. It is a story of leverage. It is a story of thermodynamics. It is a story of fluid dynamics. To truly understand the polar bear, we must look beyond its magnificent fur and imposing size. We must become detectives of science, peeling back the layers to reveal the hidden machinery within. It involves the intricate structure of individual hairs. It involves the precise mechanics of a footstep on a slippery surface. It involves the flow of heat through layers of fat and skin. We will explore the physics that allows this animal to be a ghost on the ice. We will explore the physics that allows this animal to be a powerful swimmer in frigid seas. We will explore the physics that allows this animal to be a perfectly adapted hunter. The polar bear's life is a constant negotiation with the forces of nature, a delicate balancing act performed on the world's most treacherous stage. This journey will take us into a world of hidden physics. We will ask questions that transform the way we see this iconic animal. How much force does each paw exert? How does black skin under white fur create a perfect thermal trap? What are the fluid dynamics of its powerful swimming stroke? By seeking the answers, we uncover a secret blueprint for survival, one designed by millions of years of evolution. We will reveal the hidden adaptations that make the polar bear not just a survivor, but a true sovereign of the Arctic. The story of the polar bear is the story of physics brought to life in the most extreme place on Earth. The Arctic is a realm defined by physics. It is a place of extreme thermal gradients, where energy, in the form of heat, is a precious and fleeting commodity. For any warm-blooded animal, the primary challenge is simple: how to keep the heat in. The polar bear lives its life in a constant battle against the second law of thermodynamics, which dictates that heat will always flow from a warmer object to a colder one. The bear's internal body temperature is around 37 degrees Celsius, similar to our own. But the world outside is a vast cold sink, constantly trying to steal that vital warmth. Surviving here means becoming an expert in insulation. This environment is not just cold, it is also mechanically unstable. The polar bear's home is sea ice, a platform that is constantly in motion. It freezes, it melts, it cracks, and it drifts. Walking here is not like walking on solid ground. It requires a deep, intuitive understanding of force distribution and friction. A single misstep could mean breaking through the ice into the lethally cold water below. Every movement must be calculated, every footfall placed with precision. Our exploration will begin by framing the polar bear's life through this lens of physical challenges. We will use simple physics to quantify the problems it faces every single day. We will look at the numbers behind the cold, calculating the rate of heat loss a creature of this size would experience without its incredible adaptations. We will examine the forces at play as it navigates its fractured, slippery whirl. By establishing the sheer difficulty of the problems, we can then truly appreciate the genius of the solutions that evolution has engineered. It is a story told with equations for heat transfer and calculations of pressure and stress. We will use archival science, looking back at the work of pioneering researchers who first ventured into this frozen world to study these animals. We will see early footage and field notes that document the bear's incredible abilities. These historical records provide a foundation from which modern science, with its advanced imaging and tracking technology, has built a more complete picture. By combining the old with the new, we can piece together the full narrative of how science has slowly decoded the secrets of the ice bear, revealing the physical principles that underpin its existence in this beautiful, yet brutal, kingdom of ice. To understand the polar bear's mastery over the cold, we must first look at its most obvious feature: its magnificent coat. This is not just a simple fur coat. It is a highly sophisticated, multi-layered insulation system. The coat is composed of two distinct types of hair. On the outside, we find the long guard hairs. These can grow up to 15 centimeters in length. They are stiff, they are oily, they are water repellent. When the bear emerges from the sea, a quick shake is all it needs to shed most of the water, preventing it from soaking the underfur and freezing. Beneath this outer shield lies a second layer, a dense, woolly underfur. This underfur is much softer and finer. Its primary job is to trap air, not repel water. Air is a fantastic insulator. Its molecules are spread far apart, making heat conduction difficult. The dense mat of underfur traps a thick layer of air right next to the bear's skin, creating a thermal barrier. This layer of still air is the secret to the polar bear's warmth. It is like wearing a permanent, perfectly fitted down jacket. The effectiveness of this system is astonishing. The trapped air layer is so effective that a polar bear can be almost invisible to thermal imaging cameras, except for its breath and its nose. The polar bear's fur appears brilliantly white. This seems like a simple adaptation for camouflage in a world of snow and ice. But the physics behind its color reveals a much more complex and fascinating story. The hairs themselves are not actually white. They contain no white pigment. Instead, each individual hair is transparent and hollow. The whiteness we perceive is an illusion, a trick of the light created by the very structure of the fur. As the light travels down the hair shaft, it bounces and scatters randomly off these internal surfaces. This process is known as diffuse reflection. The combination of all this scattered light appears white to our eyes. This clever design has a profound thermal advantage. Some of it is directed inwards, down the hollow core of the hair, towards the skin, but the primary insulating property comes from the air trapped inside each hollow hair. If we were to shave a polar bear, we would find a surprising secret hidden beneath its famous white coat. Its skin is not pink or pale, as one might expect. It is black. In a world of ice, why would an animal have black skin? The answer lies in the physics of radiation. Dark-colored surfaces are excellent absorbers of radiant energy. The polar bear's black skin acts like a solar panel, soaking up solar energy that makes it through the translucent fur. The bear's body is a cleverly designed heat trap. This adaptation is particularly useful on clear, sunny days, even when the air temperature is extremely low. It is a passive heating system, silent and efficient. White-looking fur, black skin, not a contradiction. An integrated system. Fur provides camouflage. Fur traps air for insulation. Black skin maximizes solar absorption. While the fur coat is the polar bear's first line of defense against the cold, there is another, equally important layer of insulation working from within. Beneath its black skin lies a thick layer of fat, or blubber. This blubber layer can be up to 11 centimeters thick, encasing the bear's entire body except for its head and paws. This is more than just a store of energy for lean times. It is a critical component of the bear's thermal regulation system. Fat is a poor conductor of heat, which makes it an excellent insulator. It provides a deep, internal barrier against the cold, especially when the bear is in the water. When a bear swims in near freezing water, its fur loses much of its insulating power because water replaces the trapped air. In these moments, the blubber layer becomes the primary insulator, keeping the bear's core body temperature stable. This blubber layer serves a dual purpose. It is both an insulator and a massive energy reserve. A polar bear's diet consists mainly of seals, which are rich in fat. This high-fat diet allows the bear to build up its own substantial fat reserves. A large male bear can store enough energy in its blubber to survive for months without eating, a crucial adaptation for a life of feast or famine. This stored energy fuels its metabolism, generating the internal heat that the blubber and fur work so hard to contain. The blubber is therefore both the wall of the furnace and the fuel pile that keeps it burning. The polar bear's overall body shape is another crucial, yet often overlooked adaptation for surviving the cold. The principles of geometry and thermodynamics dictate that the shape of an object has a significant impact on how quickly it loses heat. An object with a large surface area relative to its volume will cool down much faster than an object with a small surface area relative to its volume. The polar bear is a living example of this principle. It has a large, bulky body, which maximizes its volume. Its extremities are relatively small. Compare this to an animal from a hot climate, like the fennec fox, with its enormous ears designed to radiate heat away from its body. This is why larger animals are better suited to cold climates. The polar bear's immense size is, in itself, a powerful defense against heat loss. The polar bear's imposing stature is not just for power and presence. It is a mathematical necessity for life in the extreme cold of the Arctic. The polar bear's typical walking pace, about 5 to 6 kilometers per hour. This seemingly leisurely pace is a masterpiece of energy conservation. The key is the mechanics of the bear's gait. It employs a pacing walk. Legs on the same side move together. This creates a slight side-to-side sway. It looks clumsy but is incredibly effective. The gait keeps the center of mass stable, reducing vertical bobbing. Smooth, rolling progression carries huge mass with minimal metabolic cost. On very thin ice, the bear splays its legs far apart and lowers its body to spread weight over more area. The undersides of a polar bear's paws are covered in thick black pads. They are covered in small, soft bumps called papillae. These papillae act like the tread on a winter tire, increasing the total surface area of the paw that is in contact with the ice. The polar bear's paws are also equipped with long, thick, curved, non-retractable claws. They are always deployed, ready for action. These claws act like ice picks, providing additional anchor points that prevent slipping, especially when climbing up steep pressure ridges. Furthermore, the paws themselves are enormous, up to 30 centimeters wide. This large size serves two purposes. Firstly, it helps to distribute the bear's weight. Secondly, it provides an advantage when swimming, acting like a broad paddle. When hunting or charging, a polar bear can sprint at speeds of up to 40 kilometers per hour over short distances. When a bear accelerates, it pushes backwards against the ice with its paws. According to Newton's third law of motion, the ice pushes forward on the bear with an equal force, propelling it forward. It is an ambush predator, relying on stealth to get close to its prey, and then a short, explosive burst of speed to close the final distance. A failed hunt after a long chase is a devastating waste of precious calories. It is also about a hidden mechanism within its legs, the remarkable properties of its tendons. They are also highly effective biological springs. Then, as the bear pushes off for the next step, these tendons recoil, releasing that stored energy and helping to propel the animal forward. This process is known as elastic energy storage and release. It significantly reduces the amount of work the muscles have to do, thereby saving calories. This allows the bear to travel vast distances across the sea ice in search of food without exhausting itself or damaging its body. This hidden spring in its step is another piece of the complex biomechanical puzzle that allows the polar bear to thrive. Its transition from land to sea is often a dramatic display of physics in action. The bear's streamlined body shape helps to minimize this drag force. It often enters head first with its front legs extended, creating a hydrodynamic profile that cuts through the water smoothly. The initial plunge also has a thermal consequence. Water displaces much of the air trapped in dense underfur. Now the thick layer of blubber beneath the skin takes over as primary insulator. It is capable of swimming for long distances, sometimes for days at a time, covering hundreds of kilometers. It relies almost entirely on its large front paws for propulsion. The rear legs are held flat and trail behind, acting more like rudders for steering and stability. On the power stroke, the bear spreads its toes to maximize the surface area of the paw, pushing a large volume of water backwards. According to Newton's third law, this results in an equal and opposite forward thrust. On the recovery stroke, the bear brings its paws forward again, but this time it brings them in close to its body and turns them sideways to minimize drag. A key element of the polar bear's aquatic prowess is its ability to stay afloat with minimal effort. This is governed by the principle of buoyancy. An object submerged in a fluid experiences an upward buoyant force equal in size to the weight of the fluid it displaces. If this buoyant force is greater than or equal to the object's weight, the object will float. The polar bear's massive layer of blubber acts like a built-in life jacket. This high-fat content lowers the bear's overall body density. This makes the bear naturally buoyant. When hunting, this buoyancy allows the bear to adopt a stealthy swimming posture, with only the very top of its head visible above the water, making it difficult for a seal on an ice floe to spot its approach. It is another example of how the bear's body composition is perfectly tuned to the physical laws that govern its marine environment, making it a true sovereign of the Arctic seas. The most common technique is a patient wait. The bear finds a breathing hole in the ice. It may wait there for hours, motionless. When a seal surfaces, the bear explodes into action. It rears up, then it smashes down with powerful forelimbs. This converts potential energy into a devastating blow. Another strategy is the stalk. The bear spots a seal resting on an ice floe from far away. It begins a slow, methodical approach. Then, the final rush, a burst of speed. A timed charge. The bear must generate huge traction on slippery ice. The polar bear's skull and jaw are a marvel of mechanical engineering. The force of the bite is amplified by lever mechanics. Bite force estimated over 8 megapascals, enough to crush a seal's skull. Force concentrates on sharp canines, creating pressure that punctures skin and bone. After the kill, neck muscles and shearing teeth rip the carcass, prioritizing blubber and skin. High-fat blubber replenishes energy and insulating fat. A polar bear's hunt often begins long before it sees its prey. It begins with its most powerful and far-reaching sense, its sense of smell. Cold air is dense, so scent molecules don't disperse upward as quickly. They stay near the ground, forming scent trails that can travel for miles. Furthermore, polar bears possess a tapetum lucidum. This gives photoreceptors a second chance to absorb light, dramatically enhancing vision in Arctic twilight and polar night. It's believed polar bear lenses contain UV-absorbing compounds, acting like built-in sunglasses. This protects the retina, allowing the bear to scan the bright landscape for hours without harm. The life of a polar bear is a constant and unforgiving calculation of energy. To survive, income must be greater than or equal to expenses. Let's look at the numbers. A bear needs the energy equivalent of about 2 kilograms of seal blubber per day, roughly 18,000 kilocalories, just for resting. A successful hunt can mean a huge energy profit. One ringed seal can sustain a bear for over a week. But what happens when a hunt fails? A miss is not just a disappointment. It is a significant blow to the bear's survival calculations. Some studies suggest that the success rate for a polar bear hunt can be as low as 10%. This means the bear must endure 9 failed, energy-draining attempts for every one successful, life-sustaining meal. In the harsh Arctic environment, a string of failed hunts can quickly lead to a state of severe energy deficit, pushing the bear towards starvation. As the blubber thins, the bear becomes more susceptible to the cold. This creates a vicious cycle. As the bear gets colder and weaker, it has less energy available for hunting, making future success even less likely. The polar bear is a single, seamlessly integrated system, a living machine where every component works in perfect harmony with all the others. It is a closed loop, a self-sustaining cycle of physical and biological engineering. To see the polar bear is to see physics brought to life in the most elegant and powerful way imaginable. The polar bear is more than just an icon of the Arctic. It is a masterpiece of integrated design, a true survival machine. We have seen the polar bear as a marvel of physics, a perfectly engineered survivor. But what happens when that world begins to disappear? The greatest threat facing the polar bear today is climate change. In the Arctic, this warming is happening at more than twice the rate of the global average. The physical consequence is simple and direct. Ice melts when it gets warmer. For the polar bear, sea ice is not just a platform. It is the entire foundation of its existence. It is the surface on which it walks. It is the base from which it hunts. It is the nursery where it raises its young. As the sea ice melts earlier in the spring and forms later in the autumn, the bears are forced to spend more time on land, away from their primary food source. A longer ice-free season means a longer period of forced fasting. The bear's carefully balanced energy budget is thrown into chaos. The perfect adaptation to a world of ice becomes a tragic vulnerability in a world of open water. The master of the frozen realm is losing its kingdom. Its fate rests on the decisions we make, thousands of miles away from the silent, frozen landscapes it calls home. To secure a future for the polar bear, we must address the root cause. This means reducing our global carbon emissions and transitioning to cleaner sources of energy. The future of the ice bear is a test of our own wisdom and foresight. It is a challenge to us all to become better stewards of this planet we share. Thank you for joining us on this journey into the hidden world of the polar bear. If you found this exploration of physics and nature as fascinating as we did, please take a moment to give this video a like. And to continue exploring the incredible science behind the world around us, make sure you subscribe to our channel. There are always more secrets waiting to be discovered, more stories waiting to be told. The world is full of wonders if you only know how to look.